In this video, I will show you how to use ROS node modeling language created using the WebGME to create a launch file that will be used to run simulation using ROS and gazebo. So let's get started. I will first unpack the npm package that will let me create WebGME apps and start the server. So now my npm package has been extracted successfully into the node modules folder, as you can see from ls-lrt. So this one is the node module, cd node modules, cd webgme cli. As you can see that these are the projects that I have in the npm package, cd ec5. Okay, let's start webgme. So now you can see that my WebGME server is running. Let's start WebGME client in the browser. So create a new file, ROS node modeling language underscore demo, and I will import my file from ROS node modeling language final submission .webgmex create. So as you can see that in my meta model I have a launch type that contains all other types as per the specification of the robotic operating systems launch file specification. So I'm going to show the step by step how to create a model that will help in generating a launch file. This model will basically have relationship between different ROS nodes that will help you generate a launch file. So let's start it. So I will create a different nodes and the relationship between them. So let's create a different nodes. This will have some some parameters such as scan topic, I should change the display format so that like you can see what are the parameters I am adding. Then I have one more topic. Alright, now my one node is complete. Let's move to the other node. Now I will establish a relationship between these two nodes. As you can see that now destination is distance estimator and source is Kalman filter, it means that Kalman filter will try to establish a one-way relationship uh, with distance estimator. If we want to have a two-way relationship, then we have to create a relationship both ways like this, but we don't want it right now. So relationship will be established using from and to. So from will be inherited from the node, that is the destination, and the source will be the topic from the source. So from I think I made a mistake in stating the from and to relationship. So to will be the relationship that will have a topic that Kalman filter node is trying to fetch from the distance estimator node, and from will be the topic that it is trying to match from itself to the distance estimator. We will have another kind of the relationship between the Kalman filter and distance estimator. No, I think this is okay. So we can have some remapping from itself, so that this can be done by establishing relationship with itself. Like this. This will only be needed when your nodes are poorly designed or poorly programmed. But if you program your ROS node in the right way, then probably this kind of the relationship will not be needed. Now I will have another node called velocity estimator. It has two parameters. Then I have another node. And this will we establish relationship with Kalman filter. So this will be like this. Let's move it here. Now my launch is ready. Now let's check constraint evaluator. We have the valid plugins that are selected. So let's first check the constraint evaluator. Check constraint for entire project. So I think there is some validation. Okay. Steering based. Please provide package attribute for. Okay. So I think I have violated some constraints. So let's see. Okay, so in this node I have not provided package and type. So let's provide package and type. Type will be the same as the name. Okay, alright. Check constraints for entire project. Okay, still missing something. One among attribute value must not be null. Okay. I think I should check for probably these are the other examples that I had created. So right now I'm going to check constraints for only for this project. So this is passed. So in order to generate the code, let me delete the old examples that I had created, or we can correct it. Right. Check constraints for entire node. This is passed. Check constraints for entire node. This is failed. So let's see. So I think I got the why I was getting that error, because this attribute's name is env dash loader and I had made it like env underscore loader. So I have it was in like this, so that's why it was getting error. So I have corrected it now. So now let's check the constraint for this project. Show result. Now this is valid. All right. So now it has passed. Now we can check constraint for entire project. Okay, we're still getting some error. Okay, I think these constraints are getting applied to these as well. Now when the project validation has passed, we are ready to generate code. So let's check this. Constraint launch evaluator. Okay. Now my launch output is ready. So now save this file. Okay. So I had created a demo launch right now. So you can see that my launch file has been ready. It has a velocity node. It has some kind of one ML controller node, and then distance estimator node, Kalman filter node, and some as an example from my example model, you can also check the launch file it has generated. So this is how we have generated the launch file. Now I will show you how to use this launch file so that you will be convinced that it really works. So let's extract this. I will extract it to the valid workspace of the ROS. So you can see that this is the launch demo.launch. Okay, I will now run it. But before that, I should launch the necessary configurations to run this launch file. So let's try to run the launch file, test the launch file whether that is working or not. And I am pretty much sure that we may get some error, maybe because I have not configured properly or somehow. So this is, I have loaded the one car. Alright, so let's see how it sounds like right now. So right now you can see that I have a 2 car and none of them are moving, and the idea will be to move one car so that my newly created launch file will so it has started moving slowly. Let's run the newly created launch file, and nothing happened. So let's see how. So as you can see that publisher is none, and probably I have forgot to add the namespace to all the nodes. So let's do that. Let's kill the simulation first. And add the node namespace to all the nodes. So namespace is azcar_sim. So namespace will group all these nodes into a single group called namespace. Now let's regenerate our file. Now let's test it. this is our generated launch file. So let's see something has happened or not. I am pretty much sure that. Okay, let's see. So as you can see that some now we can see some publisher as AZ car and ML controller, which was basically this node, and let's see if it's producing any data or not. And it does not appear to produce yet something. So I think, but you can see that it's trying to produce something. Oh, I actually put the wrong value. So I think it's because it's 0.1, but you can see that it's trying to move. So I think that's for it. I think probably we need to correct something in the our simulation configuration, but otherwise the my generated launch file is working pretty much nicely. So that's it for today.